Good people, welcome back to this lessons on Centroids. This is my first one I'm going to work through. People, there's a section. Well, you can see it looks like the letter L. So we generally in structure we call that an L section. There's the dimensions. 46 there. It's 26 at the bottom. 400 high from there to there. 200 from there to there. Okay. Now people, the question would be determine the position of the centroid, okay, and you can determine it from a particular point. Let's say I'm going to say this is going to be the point over here, and I'm going to call this point A, which is the bottom there, okay. And then the first thing we do is we divide it into sections we know. Now when I say sections we know, just look at this over here, okay. I'm going to, this table will be, I'll post this table on Blackboard as well, and it's called section properties of some common sections. There's a rectangle, okay, that horizontal distance is normally known as B, that distance is D, so the area of course will be BD, and then this here, very important, that's what I want to point out. This second column there, third column, there's the sketch, first column, so that's the area for sections. There's a column called distance from the extreme fiber to the centroid. Extreme fiber just means the furthermost points. That will be a furthermost point, that will be a furthermost point. These are all beams, so there's a rectangular beam. The beam is coming out toward you or going into the page. So that there will be the topmost extreme fiber, and that will be the bottommost extreme fiber. Okay, and then the distance from the centroid to the extreme fibers from there to the top of the bottom is equal to D over 2. D is the full height, D is D over 2. Okay, for a triangle, notice I'm not concerned about my second rectangle, I'm not concerned about my second triangle, I'm only concerned about the first one there. Okay, there's my triangle, and the distance, that's little d, okay. D is always vertical and B is always horizontal. That stands for breadth and that stands for depth. Okay, we never talk about the height of the section, we talk of the depth of the section, how deep it is. Okay, the height, that's the height of a person, but it's the depth of a section. Okay, and in a triangle, if that's D there, the distance from the centroid to the topmost point is 2/3 D, or the distance from the centroid to the base there is D over 3 or 1/3 D. Okay, so 2/3 D plus 1/3 D makes 1 full depth. Okay, but we will generally go with 1/3 from the bottom. Okay, circle, D is diameter. Okay, big D is diameter, and of course because we said from our notes previously that the centroid is the geometric center of a cross section. So the centroid will be exactly in the middle here, so it will be D over 2, which you also call the radius. That's right. Okay, half of D is also the radius. Right, and then lastly, semicircle. Okay, and notice there, if we cut the semicircle through the middle there, the center of gravity originally sat over there. Once that other half circle is taken away, the position of the centroid will shift, and it will shift to where there is more mass, because the centroid is also known as the center of mass. Okay, so if I take this lower half away, the centroid will shift upwards. If I take the upper half away, the centroid will shift to the lower half. But we took the lower half away. So the distance, very important. The distance from the base there to the center of gravity, I'm going to use this one here, is 4r over 3 pi. Okay, and by the way, you need to remember these. If you get them in an exam, I won't give it to you, you need to remember these. Okay, so the position of the centroid, the distance from the base of the semicircle, vertically upwards, to where the position of centroid is for a semicircle, it is 4 times the radius over 3 pi. If this semicircle was turned through, if it was turned through 90 degrees, that means this distance will be will be on the horizontal. Okay, so people, there's 4 sections. There's a rectangle, and of course if we have a square, it's dead in the middle. There's for a triangle, 1/3 from the base. Semicircle is in the center, and for a semicircle, the distance is 4r over 3 pi from the flat bit upwards. Okay, I'm going back to my note there. So people, the first thing we do is we divide this, we call it the compound section. We divide this compound section into sections that we know. Why do we know? Because we know what that is and what that is for each of the sections there. Okay, and we want to find the centroidal position for the section here. Okay, right, so I'm going to divide it up. Let me just I can either divide this like so, okay, or I can divide it that way, but I'm going to divide it like this. So the centroid for this section is sitting in the middle there. Take this away, sitting over there. And the centroid for this section is sitting over there. Okay, now people, I'm going to take my time with the first one. I'm going to explain a lot of things, and then when we get to the second one onwards, I'll explain a lot less because you'll understand it better then. Right, now people, we saw that from over there, there's the y-axis and there's the x-axis. I'm going to draw these axes for each of these 2 elements. Okay, there's an element, there's an element. So, there's my x-axis and there's my y-axis. Okay, so that's x. Let me draw the axis for this one while I'm at it. Okay, I should have drawn this in first and then made the little dots there. That should be. Okay, so that's a centroid for element 1, and that's a centroid for element 2. Okay, and that's the x-axis of element 1. Call this element 1. Call this element 2. Okay, and that's the y-axis for element 1. And that there is the x-axis for element 2, and that's the y-axis for element 2. People, now, these axes, okay, notice they're all small letters. There's a reason for that. You do it exactly as I say. You copy me. If you don't, you will confuse yourself later on. Okay, so that's the x-axis and the y-axis for each of the elements. You could have divided this elements the other way if you want to do, but for now we're doing it like this. Okay, right, so there's my axes for the 2 elements. The question is says find the position of the centroid from point A. That means the distance from there up to there, and the distance from there to wherever. Okay, and there's a formula for that. Alright, the formula is given by, okay, so, and we read that as bar y, okay, and bar y is the vertical distance this way here, okay, and is used, and bar y is terminology used in centroids, and here's the formula. Okay, you need to remember that. Okay, I'll explain this as I go along. Right, that's the sum of A is the element of each area, okay, and y is the distance. Okay, so, right, you got your thinking caps on? Element 1, what is dimensions? It's 40 by 400. It's 40 by 400. That little dot is multiplied by, right, are you listening? Y is the distance from the centroid of the element to that line that we have taken moment areas about. Now remember when we did moments, what was the definition of a moment? A moment was a force multiplied by a distance, a perpendicular distance. Here we are taking moments of areas, so it's an area times the distance. Okay, so that there is the area of element 1, and that there is the distance, and y is defined as the distance from the centroid of the element to the line. We are taking moments about that line over there. And how far is it from there to there? It is 200. Why is it 200? Because from this table here, the table says that if we have a depth of 400, that means the distance from the centroid to the furthermost fiber is d over 2, so it's 400 over 2. That is why it's 200. The table told us to do that. Okay, so that's 200. Close the bracket, plus. Why plus? Because it's the sum of. We do the same thing with element number 2. Now element number 2, people, be careful. Why? Watch this. Other people think, oh no, I don't need to be careful. You need to be careful. From there to there is 400, and from there to there is 40. From there to there is 200. So the area of element 2 is not 200 by 60, but that distance there is 200 minus 40. So it is 160. Be very careful. Okay, be very careful about that. So what's the area? It is 160 by 60. 160 by 60. That's the area multiplied by y. What's y? Y is the distance from the centroid of the element to the line we take in moment areas about. And how much is it? It's 30. Why? Because from our table, d is 60, so 60 over 2, so it's 30. Over the total cross-section area of the object, which is 40 by 40 plus 160 times 60, and that's the easy bit. So it's 40 times 40, 40 times 400 plus 160 times 60 is equal to. Right, let's do the calculation. Now pause this for a second so we can work it out. Okay, I got an answer of 136.25, 136. Check my answer, I could have made a mistake. Hope I got it correct. And notice there, it's a distance. The distance, okay? It's a distance. And it's, what does it mean? It means, and because why it's vertical, it means this. Let me just. What does it mean? It means that this distance here is the distance from A all the way up to there, and that's by y, and it's equal to 136.25. Okay, and that there is the x axis. That there is the y axis. Okay, and where they intersect, that's the position of the centroid for that whole cross section. Did you get that? Okay. Y, bar y, is the distance, the vertical distance from the point we're working about to the x axis. Okay. The question wants us to determine the position of the centroid. Are we done? No, we're not done. We know how far that axis is from here, but we don't know how far the y axis is from over there, and that is what we're going to work at now. Okay. Right, let me just get this back here. Bar y, as you guessed. Sorry, bar x, my part, bar x. The same, bar x. Right. You'll see there that when we do bar y, we are working with vertical distances. When we work at bar x, we're working with horizontal distances. Right. A stands for the area of element 1. What's the area of element 1? 40 by 400. 40 times 400. What is x? Are you tuning in? X is the distance from the centroid to the line we're taking moments about. The distance from there to there. And how far is it? It's 20. Why? Because from our tables I showed you previously, it's d over 2. So it's 20, 40 over 2. Plus. Why plus? Because it's the sum of area of element 1 is 160 times 60 times x. What's x? Are you tuning in? X is the distance from the centroid of the element all the way to where we've taken moments about. A lot of people say it's 160 over 2. Wrong. Okay? The distance is 160 over 2 plus 40. Okay? So it is 80 plus 40, so it's 120. Did that sink in? Did that sink in? Let it sink in. It's not 80. It's not half of that. It's 80 plus 40. Right over the area, which we know already. So it's 40 by 400. 160 times 60. Is equal to, and we should get the distance. If you leave that out, and you leave that out, I take off 2 marks because I'm feeling in a good mood. Okay, work at the answer. I'll do the same for myself. Right, the answer I get there is 41.82. But it's small. But it's not, it looks a bit on the small side. I'm going to check mine again. I should have let me check mine again. Let me check mine. Give me a sec. Check yours again. People, I think I got a better answer there. I think the first one wasn't correct. Is I get 57.50. That 57.50 millimeters. Okay. What does that mean? That is the horizontal distance from there all the way to there. So that's bar x. Okay. Just draw a little line in there. Okay, people. The question says determine bar x and bar y, or determine the position of the centers for that cross section there. That's the answer. So bar y is 136.25, bar x is 57.50. That means that from the bottommost fibers up to there, the distance is 136.25 millimeters, and from the leftmost fibers to the y axis, it is 57.50. Okay, people, that's the first example done, and I'll do another one in the next video.